Hello, dear students. I, Abhinav Negi and Dheeraj sir, welcome you all on BYJU'S exam prep. So, guys, the wonderful response you all have given for the revision series. First of all, we both would like to thank you all for this wonderful response. Guys, in this revision series, what we have done, we have completed each and every chapter. First, me and Dheeraj sir have taken the stress strain, elastic constants, Poisson ratio. Then I have taken bending and shear stresses. Then sir, principal stresses. Then I have taken SFD, BMD. Then sir has taken the slope and deflection. Then I have taken torsion, spring and pressure vessels in a revision point of view. Now, along with every class, we have done some numericals also to understand that particular topic better, for which we are revising. Now we are taking a complete test. It will be around 1 hour. First, Dheeraj sir will be taking his questions. Then some of the questions of SOM I'll be taking. And this session will be of all the chapters that we have discussed. So keep liking the session and share with all the students and analyze your performance with this test. Over to Dheeraj sir.
Yes, guys. So as sir have already said, we will be starting with the questions only here. And in this session, guys, we will be covering all the different types of questions. And I and Abhinav sir have tried to make it a session with all the types covering, as well as they would be covering all the concepts. Okay. And we have made it some questions easy, some question difficult, some question lengthy. So it is going to be an overall mix of all the types. Okay. So we will be starting it, and this session will go for 1 to 1.5 hours. So shall we start, sir?
Okay, sir. Okay.
Fine. So guys, we are starting the session. This is Mechanical by Dheeraj Sardana is the Telegram channel link. You can join this Telegram channel to get the PDF of this session and all the updates. Okay. And if anyone of your known have qualified ESC prelims and mains, you can inform them to come for the interview. There are more interviews going on. Okay, they can share the details of theirs in the description. Link is there. So first question, guys, the principal stresses at a point in an elastic material are 30 MPa compressive. So sigma 1 is minus 30, sigma 2 is plus 20, and sigma 3 is plus 50. So these are three principal stresses given to us, and they have given the Poisson ratio as 0.25, Young's modulus as 200 GPa, and they are asking for volumetric strain. Okay, and guys, the expression for volumetric strain you already know, 1 minus 2 mu upon E, and then we will be having sigma 1 plus sigma 2 plus sigma 3. So this is the formula we will be using. Solve it and get the answer. As I said, we are covering all the types. This is the type of question related to the volumetric strain. And guys, do like and share the session so that others also can reach. Yes. Solve it, guys. Solve it. Let me share. So what would be the answer, guys, for this question? Tell me that. Okay, Malesh said D is the answer. Anupam, good morning, dear. So let me make it in such a way that I can see your comments. Okay, so Malesh is saying the answer to be D. What about others? CADMAC, Aspirant, Anupam? Tell me the answer, guys. And you know, tonight we have mathematics session also. Tonight we have mathematics session at 8 p.m. And that 8 p.m. session will be related to probability today. Today we will see the questions on the cards, on the total probability, on the Bayes theorem, on the conditional probability, all these topics. Although Bayes theorem covers conditional probability only, but still I said separately. Okay, so we are going to cover all of them. So guys, what would be the answer? D. Is it coming D? Tell me that. 1 minus 2 mu. 1 minus mu is given as equals to 0.25. So 2 into 0.25. then divided by E. E is given as 200 GPa. So 200 into 10 power 3, because stresses will be in MPa. Then you can put minus 30, plus 20, plus 50. Yes, aspirant is saying C would be the answer. And guys, I would like to tell you that C is correct. So aspirant have given the correct answer. Malesh, you have done some mistake. Yes, what about you, Cadmac? Tell me. आज कहाँ busy है भाई सब लोग? Why all the people have not joined today? Okay. So C would be the right answer, guys. Moving to the next question, guys. Next question is this. This is from stress strain diagram. It is saying that a sample of a metal is listed in tension, and it is found that there is a strain of 0.008 at a corresponding stress of 450 Newton per mm square. On the removal of the load, a permanent strain of 0.0015 is found. The value of modulus of elasticity. So my dear, they are saying they are going to load like this. After that, they are unloading. And when they are loading till a value of 0.0080. And at that time, the stress value is 450. And there is a permanent strain coming, that is 0.0015. And you need to find out the Young's modulus. You already know Young's modulus is nothing but tangent theta. So we have tried to have all the types of question in this. Solve it, guys. Solve it. Aspirant, Cadmac, Malesh, Anupam. What would be the answer, guys? Solve it. Solve it, guys. I feel you can write it as Young's modulus, which is tangent theta, y by x, 450 by 0.008 minus 0.0015. This will give you the Young's modulus. This time Malesh and aspirant have given the correct answer. 6.92 into 10 to the power 4. 6.92 into 10 to the power 4. Newton per mm square is the right answer. Very good. बहुत ही बढ़िया. Moving to the next question, guys. This is a very good question from principal stress chapter. Here he is saying the principal stress is at a point on a body is subjected to a state of plane stress, 10 MPa and 20 MPa. So you can say 10 MPa and 20 MPa. The magnitude of the shear stress on a plane in which the normal stress is 12 MPa. So they have given like this. And they are saying that there is a plane. There is a plane at which normal stress is 12. They have not given theta and they are asking what is the shear stress at that plane. Yes, Papa ka ghoda, good morning, bhai, kaise ho aap? Solve it, guys, solve it. So I feel very easily you can solve it. I will give you the hint here. Sigma XX is 10 MPa. Sigma YY is 20 MPa. And I feel everybody aware sigma theta formula. Sigma XX plus sigma YY by 2 plus sigma XX minus sigma YY by 2 cos to theta plus tau XY is sin to theta. Now here tau XY is 0. So this component will become 0. From here you can find out cos to theta. Once you get cos to theta, you know sin to theta will be equals to 1 minus cos square to theta. Once you will get this sine to theta, you can find out the shear stress, which is xx minus yy by 2 sine to theta minus tau xy cos to theta. Once again, tau xy is 0. So you can very easily find out like this. Solve it, guys. Solve it. Everyone. Malesh, Anupam, CADMAC, Aspirant, everybody. And do like and share the session. I was expecting more students today, but I feel as it is the last session. India Australia match to sham mein hai. Okay, solve it, guys. So tonight we have mathematics class of probability as well, and we will be covering today the pending part, and next week we will be going for random variable. Okay, and from next week I will increase the duration of the class. We will keep only one class on Sunday, but of 2 hours. So next week we will be going for random variables. The target is to complete probability next week, and then we will be starting the differential equation next month. Okay, Amin is saying the answer to be 4. What about others? So Amin is saying the answer to be 4. First of all, when you will find out cos to theta, it is coming out to be 3 by 5. Then sine to theta will be coming out to be 4 by 5. So the answer given by Amin is exactly correct. It will be coming out to be 4 MPa. Answer will be 4 MPa. Very good. Aspirant, Malesh. Arey bhai, it is coming out exact 4. I don't know how you get 3.45. Moving further, guys. Next question. So this is a wonderful question. Once again from the same chapter. So you can see this is 60, this is 26. Okay, this is given to you. So here they are saying two angles, planes AB and BC, which are at right angles, carry intensity 26 at AB, tensile is 60 as shown in the figure. Find the normal and shear stress on the plane AC inclined at 25 degree. You need to find out sigma theta and tau theta. This is what you need to find out. You know, angle is given as 25 degree, anti-clockwise from X phase. So this is theta. Rest formulas, you know. Solve it. Satya, okay, you need PPT of theory of machines. Okay, I will check it, Satya. I feel it should be available on my Telegram channel. Or if I remember, yes, it should be. It should be, but if it is not there, I can share you the handwritten notes. Danish, good morning. So solve this question. Solve this question. Formula just now I have written. Formula just now I have written. So this is sigma xx. This is tau xy. Sigma yy 0 for this case. Solve it, everybody. This is not a very big session. This is a 1 to 1.5 hours at the max. Solve it, guys. Okay. So I feel B is not the correct answer. I feel you would be getting this 69.2 and 6.26. Check it once again. Check it once again. Yes, Dhanesh, Satya, Malesh, Aspirant, Amin. Bolo bhai, bolo. Shall I write the formula again? By sigma theta is sigma xx plus sigma yy by 2 plus sigma xx minus sigma yy by 2 cos to theta plus tau xy sin to theta. So you know sigma yy is not given, sigma yy is 0. So rest all the things are given. Theta is 25 degree. When you will put the value, you will get the answer. Tell me, guys. Are we getting 69.2 for this? A is correct, Aspirant. So you will get 69.2 for sigma theta. And when you will go for tau theta, xx minus yy by 2 into sin 2 theta minus tau xy cos 2 theta. So when you will be solving for this, you will be getting a 6.26. The answer will be coming out to be 6.26. A would be the right answer, guys. So this is from bending stresses. Have you seen I am skipping some question? Actually, those questions are for your homework. Okay. I have already written the solution for every question. So that's why I'm going alternatively. Some questions are for your homework. Next question is, this is a semicircular beam. And the beam as shown in the figure below is subjected to pure bending. If the cross section is a semicircle, the ratio of maximum tensile stress to the maximum compressive stress. So my dear, you can see this sagging moment. So you must be aware of the centroid of the semicircle. It will be coming somewhere here. And I feel everybody knows that it will be at a height of 4r by 3 pi. It will be at 4r by 3 pi. From where? From this. Okay. So next, what will be this one? This is r minus 4r by 3 pi. You know, in the top fiber, there will be compression. In the bottom fiber, there will be tension. So if you want to find out sigma tensile by sigma compressive, it will be y, sigma tensile is downward, y bottom by y top. So it will be 4, okay, it will be r minus 4r by 3 pi divided by 4r by 3 pi. Solve this one, guys. This is a unique type of question because till now in the exam, they have not given about this cross section. So try to solve it, guys. 4r by 3 pi. Yes, solve it, guys. Solve it, solve it, solve it. Solve it, solve it, solve it. Tell me, guys. Tell me. Okay, Satya is saying 1.355. What about others? .356. Okay. So at top fibers, we have compression and bottom fiber, we have tension. So they asked about sigma T by sigma C. I feel I have done it opposite. It will be sigma tensile by sigma compressive. Tensile is at bottom fiber, na? So it should be 4R by 3 pi divided by R minus 4R by 3 pi. Because it is directly proportional. Yes or no? I have written it, this value is wrong. So I feel this will be the answer. Now please tell me, I feel you are getting inverse values. Please tell me the answer. 4R by 3 pi divided by R minus R. 0.73 is correct. 0.73 is correct. I have written here correctly, but kept the values opposite. Okay, so answer is 0.73. That is correct. They have mentioned also na round up to 2 decimal place. So moving to the next question, guys. This is about the maximum shear stress. So we are covering everything. You can see a beam of rectangular section is subjected to transverse loads. A section where shear stress at 1/4 of the beam depth is 120 MPa, the maximum shear stress is. So this is the cross section given. They have given that it is subjected to some shear load and 1/4. Let us say this is 1/4. This is D by 4. D by 4. And at this, they have given you the value of shear stress. At this, they have given you the value of shear stress. That is 120 MPa. And they are saying find out the maximum shear stress. This you need to find out. And obviously, this distance is also D by 4. D by 2. Yes, guys. Okay, no issues, guys. So, you know, here shear stress is coming out to be maximum shear stress for rectangular section is 3 by 2 of tau average. 3 by 2 of tau average. So, guys, just solve it and tell me what would be the right answer for this one. Solve it and tell me what would be the right answer for this much. Tell me. You also are aware of tau at any fiber is SAY bar upon INAB. Okay. Tell me, guys, tell me. S, A is BD. What is Y bar? D by 4 plus D by 8. INA is BD cube by 12 into B. So from here, you know that tau is 120. So you will get 120 is equals to, you will get here something in form of V and BD. I feel as per my calculation, we will get 9 by 8 V by BD. 9 by 8 S by BD. That is what we are getting. So guys, once you are getting this, you know the answer is 3 by 2 S by BD. So you got one value, you need to take help from this and then get the value. So S by BD value you need to calculate and put it here, you will get the answer. Let us see how many of you give the right answer. This is a new type of question because till now they are either giving all the cross section, you find out average, then you find out maximum. This time they have given you stress at a particular fiber. Okay, so that is the beauty of this. So just solve it, guys. After 1 to 2 more question, then Abhinav sir would be joining. So I have taken one question from simple stresses, one from principal, one from bending, one from shear. Okay. Now I am coming for one on SFD BMD as well. Is it clear for everyone? Please tell me that. Tell me the answer. Solve it, guys. You are not doing calculations fastly. Very good. Amin have given the answer. It will be 160. So from here you can find out S by BD to be 8 into 120 divided by 9. When you will be putting it here, you will be getting tau max to be 160 MPa. Okay, so B, Malesh is correct. Very good, Satya, Malesh. So guys, now we are having, okay, there is a scholarship test on 24th of September. If you want 90% scholarship on GATE preparation program, you can give this scholarship test. The link is there in the description. You can register now for this. There is a workshop on 27th of September, will be taken by Richa madam, and it will be on last 120 days preparation strategy to ACE GATE 2024. So guys, be ready for that. Download the app if you have not done yet, so that you can get there also benefit. Next question is which one? Next question is this one. Yes, from SFD BMD. As some questions sir is also going to take, that's why. This is figure shows a simply supported beam overhanging to the left. The beam carries a uniformly distributed load throughout. This is the loading and you need to tell about the BMD. So these are the 4 options for BMD. Once again, I am showing you the loading. I am showing you the loading like this. This is the loading. You need to tell which one is BMD for this. Which one is BMD for this? Which one is BMD for this, guys? Which one is BMD for this? First of all, if you see this, this is, let us say, A, B, C. You can directly solve. You can see there is no point moment throughout the beam. So we cannot have jump in the bending moment diagram. So that is why C and D are directly wrong. Now you need to choose from A and B. You need to choose from A and B. So let us see which answer you will give. This is L by 2 and L. This is W kilonewton per meter. Try to solve it, guys. Try to solve it. You can get an idea once you get the support reaction RC and RB. Okay, then you will be getting the better idea. So once you will find out RB and RC, then you will be getting the better idea. Try to solve it, guys. Try to solve it. Yes, 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 everybody. Very good, guys. Very good. Satya is saying answer is A. Very good. So if you see RB and RC, my dear, you know that you can also go by the method RB plus RC is equals to W into L plus L by 2. This is going to be the first equation. And then, my dear, you can also go for the moment equation summation. Moment of C is equals to 0. For that, what you will be getting, you will get RB into L minus W into L plus L by 2. This is the total weight will be acting at L plus L by 2 by 2. So this will give you the value of RB when you will equate it to 0. Then you will get the value of RC. So what are you getting the value of RB and RC? By that you will be getting this value is coming out huge positive. So as it is coming out huge positive, when you will take a summation, this is creating hogging. So that is for sure. From here it should be a, it is creating sagging. So there should be a positive bending moment, which is there only in A option. So that is why B is also wrong. So we need not to go for the complete calculation. Just by support reaction, you can get an idea. Okay. But you have to calculate support reaction because you don't know whether they both are positive or negative. If it is coming negative, then you have to go like that as well. Okay. So that is the point which you need to take care of. Is it clear for everyone? Is it clear for everyone? Please tell me that. A is correct. Any student have any doubt? Balesh, Papa Ka Ghoda, Satya, Amin, Aspirant. बी ऑप्शन में लोड नहीं है. अरे भाई ये तो बेंडिंग मोमेंट डायग्राम ना, लोड कहां से आएगा? दे आर बेंडिंग मोमेंट डायग्राम ना, तो वेयर इज द लोड? लोड कहां से आएगा? दे आर बेंडिंग मोमेंट डायग्राम. So the point is they have given this loading diagram. This is the loading diagram, and they are asking which bending moment diagram is correct. If you see all the four, you can see in C and D option there are jumps in the bending moment diagram. So when we are having jumps in the bending moment diagram, for this is possible only if we are having point moments. If you see there is no point moment, so C and D cannot be correct. So now from A and B we need to see. So A and B, one way is we can calculate by complete calculation. The second way is we can check whether it will be starting from positive or will be starting from negative. For that I need the value of RC. If RC value is positive, it means this direction is correct and this will be creating sagging. So if this will be creating sagging, so obviously it will be coming positive. So to make it positive, only this one is correct. Now you got it? Is it clear, everyone? Please tell me that. Is it clear, everyone? Please tell me that. Is it clear, guys? So this is the last question from my side. Now Abhinav sir would be taking charge after that. The correct shear force diagram for this. So you can see this is an axial load acting 10T at 0.1 meter. So this is 10 meter long beam. You need to tell which one is the correct SFD. Which one is the correct SFD? So you can see first of all the diagram. And I feel everybody aware that for this, we will be making one force here, other force here. This and this will be making a couple. So this will be making a couple like this. So what we are getting actually, we are getting this. One support, other support, point moment and axial load. What is the magnitude? 10T. 10T into 0.1 meter. So you can tell me which SFD will be correct, guys. Which SFD will be correct? Which SFD will be correct? You are having the options. Which shear force diagram will be correct? This is a bending moment acting 10T into 0.1. Total length is 10 meter. I feel you know how to find out this RA and RB. If you want to find out R, here answer is plus minus net moment by total length. So by that only you will get an idea that one reaction will be coming negative, other will be coming positive. So which one should be the correct one? A, B, C or D? A, B, C or D? If you will find out the reaction, what is net? अरे भाई ये BMD नहीं है, SFD है. Look at it. SFD, they are not BMD. ध्यान से देखो, they are SFD, they are not BMD. If it is SFD, then my dear, you can see first of all reaction. It is 10T into 0.1 divided by 10. It is 0.1T. So my dear, as you are getting this to be minus 0.1T, this is plus 0.1T. Minus means assumed direction is wrong, plus means assumed direction is correct. Why it is coming like that? You know, this moment is going to go like clockwise. This force is also trying to go clockwise. For same direction we have minus, for opposite direction we have plus. Here it is clockwise, it is anti-clockwise. So that's why this reaction is positive. So this is positive, this is negative. Throughout beam, there is no point force. So there cannot be any jump in between. So that is why this is jump, this cannot be correct. Jump cannot be correct. Okay. And this can be possible only if we have UDL type of loading. So what would be the right answer? A, because we are having one jump here, one jump here. SFD it is. Those who are saying B, they are feeling it like I am asking BMD. Then also it is wrong. It is not even BMD. So Malesh, you got it? Malesh, Satya, Amin, everybody understood? This is last question from my side. Now Abhinav sir would be coming. Got it? Okay. So I am leaving here. Over to you, sir.
Okay, thank you, sir. So guys, next question again from SFD. The beam, we'll be doing easy questions initially. The beam is loaded as shown in the figure that the maximum shear force experienced by the beam. Okay, since it is a symmetrical beam, total load is 4P. So the upward load will be 2P and 2P both sides. Okay, both sides it will be 2P. Both sides it will be 2P. Correct? Because total load is downward is 4P. Now, if I make the SFD as per AN method, Abhinav Negi method, I hope you have seen that. Upward load shear force jumps by 2P. Then no load shear force will be constant. Then downward load shear force fall. I hope you have seen this method of mine. Jump from 2P, upward reaction, what I told you. Shear force will jump, then fall from P. So it will reach at P. Then constant, then fall downward load 2P, it will fall by 2P. So plus P, it is falling by 2P, it will be reaching minus P. Then again, for downward load of P, it will fall by again P, it will reach minus 2P. Then here, then guys, upward load 2P, so it will jump by 2P. Of course, don't see the magnitude, this and this magnitude both are same. Guys, always, what is the maximum shear force experienced by the beam? The maximum shear force is 2P. Here or here, the maximum shear force is 2P. Now guys, listen 2 points here. Everyone, the question was super easy. Listen 2 points here. First point, everyone, that for symmetrical beam, if a beam is symmetrical, then SFD will always be anti-symmetrical and BMD will be symmetrical. Okay, this symmetrical means SFD is anti-symmetrical, this plus, this minus. Okay, like this also, na? Like this also. So SFD is and whatever, vice versa, and BMD is symmetrical. Okay, like this. Okay, so SFD is anti-symmetrical, BMD is symmetrical. This will be like this. Okay, and next point, that when point load is acting, shear force is not defined. Guys, here shear force is not defined. Here shear force is not defined. That is why I'm saying maximum shear force here. Here, I'm not saying it here. Where point load acts, shear force is not defined there. Give me yes or no. Not understood, let me again do it, tell you with some different example. Suppose this P is exactly at the center. So this is not exactly at center, might be this is 0.7P, this is 0.3P. So here if I cut a section, here if I cut a section, this is XX, this is XX. So down upward load 0.7P. So here the downward shear force should be 0.7P for balancing. So this is the shear force. This is the shear force. But when I cut the section exactly here to find out the shear force, then I don't know if whether to include this load or not. It will be coming left or right because I have got exactly there. So shear force is defined just before that or just after that. Okay. Now this question, everyone please, let me know. For a circular rod with diameter D, the bending tensile stress due to applied movement is M, is same as the shearing stress related to the relation. It should be if the maximum tensile stress is same as the maximum, because shearing stress is changing across the cross section. Same, the bending stress is changing across the depth. Neutral axis, it will be 0. So both maximum are same. So the maximum will be M by I into Y max. So M by I is 5 by 64 D ki power 4 and Y max is D by 2. So that is 32m by pi d cube. Similarly, the maximum shear is given by 16t by pi d cube. So 32m by pi d cube is equal to, this is pi, is equal to maximum shear stress in a solid circular shaft is this. From here, T is equal to 2m or m is equal to T by 2. Everyone understood this? Everyone understood this? Tell me please. Okay. Now what is the slope at A? This is A, this is B, and this is W naught sine pi x by L. Here, the loading is W naught sine pi x by L. I am writing it again. W is equal to W naught sine pi x by L. Listen here. The loading is W naught sine pi x by L. Suppose x I am measuring from here, left to right. Then tell me what is the W at x is equal to 0. At x is equal to 0, W naught sine 0 will be 0. So it is 0 loading here. Now, everyone, aspirant, Malesh, everyone guys, if I want to find at x is equal to L, W at x is equal to L. So sine pi is again 0. So at x is equal to L, it is again 0. And variation is not 1 degree, it is not 2 degree, variation is parabolic. At x is equal to L by 2, aspirant and everybody, L by 2 it is sine pi by 2 is 1. So it is W naught. So here it is W naught, and this variation is not 1 degree. This is not 2 degree, not 3 degree. It is parabolic. It is parabolic. Got it? Now what is theta A? That is the question. Come on, Ghoda Saab, Satya, aspirant, tell me. Tell me please. Tell me please. बता दो. See, EI d2y by dx2 is equal to m, or I can say m d2y by dx2 is equal to m by EI. Differentiate it one more time. d3y by dx3 is equal to differentiation of m is shear force. Shear force I am representing with V. V by EI. And differentiate it one more time, you will be getting d4y by dx4 is equal to differentiation of shear force is loading intensity, and EI I can put it here. So I have to start from this equation here, because bending moment and shear force is very difficult to find out here. Bending moment and shear force is very difficult to find. Guys, in 2 degree load, in 1 degree we can find. How to find? First of all, reaction here. So suppose reaction is total load, that will be the area under loading is total load, divided by 2. Sine is symmetrical from 0 to pi. From 0 to pi by 2, pi by 2 pi, it is symmetrical. So total load upon A. But still, after finding the reaction, it will be very difficult to find bending moment at x distance. Okay, so we cannot start from here. So for such equations, we should start from here. For such equations, we should be starting from here. Okay. Okay. Give me yes or no. Now, EI d4y by dx4, downward loading, let me take it negative, minus W naught sine pi x by L. Any doubt till here? Give me yes or no. Any doubt till here? Give me yes or no. Give me yes or no. Give me yes or no. Any doubt? Any doubt? No doubt. So now integrate this. EI, integration of this will be like this, and integration of sine is minus cos. So minus minus cancelled. It will be W naught L by pi cos pi x by L plus constant integration C1. Because after integration, a constant also added. Because after integration, a constant also added. Now, this constant will be 0. I'm 100% sure. How? Because this is a symmetrical figure. I just told you symmetrical will be SFD anti-symmetrical, correct? So at x is equal to L by 2, shear force has to be 0. Guys, for every symmetrical beam, I told you SFD anti-symmetrical in the first question. So anti-symmetrical means one side positive, one side negative. So it is passing from here, 0. And one more thing, what is the shear force here? Shear force here is summation of force from the left. So this reaction will be equal to this load, na? Because reaction is half of the load. Total load ka half, because symmetrical. So at here, this reaction is equal to half of the load, na? Because reaction is total load ka half, and this is the half. So it will be 0. So d3y by dx is 0. We are at cos at x is equal to L by 2. So this is 0 at x is equal to L by 2. So at x is equal to cos pi by 2 is also 0. So this shear force EI d3y by dx is shear force. This is 0. This is 0. 0 is equal to 0 plus C1. C1 is equal to 0. Now again one more integration. EI d2y by dx2. Integration of cos is minus sine. Sorry, it is integration of cos is sine. W naught L square pi square sine pi x by L. One more integration C2. And I know this will also be 0. I know this will also be 0. How you know, sir? How you know, sir? Because d2y by dx is bending moment. Bending moment at pin support is 0. So at x is equal to 0, d2y by dx2 is m. This should be 0. At x is 0 at support. So x is equal to 0. 0 is equal to 0 plus C2. C2 is equal to 0. Now integration this one more time. EI d2y by dx2 integration is EI dy by dx. Integration of sine is minus cos. W naught L cube pi cube cos pi x by L plus C3. This is also 0. For symmetrical beams, always the deflection shape will be like this, and here the slope will be 0. So put x equal to L by 2, the slope, EI dy by dx is slope, it has to be 0. At x equal to L by 2. L by 2 means cos pi by 2. 0 is equal to 0 plus C3. C3 is equal to 0. And if I want, this is slope na. If I want theta A, put x is equal to 0. So cos 0 is 1. So minus W naught L cube by pi cube cos into 1. So theta A is equal to minus W naught L cube upon pi cube into EI. Give me yes or no if you have understood this. Give me yes or no if you have understood this, guys. Come on. बता दो भाई. बता दो भाई. Please. 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 Tell me. Any doubt? Any doubt? नहीं बताओगे? No. हम तो नहीं बताएंगे, कुछ कर लो. Okay. चलो. Is there any short? This is shortcut only, yaar, Satya. Now, what is the maximum principal strain? Epsilon naught in this direction, the strain is 400. This one. This one. Okay, epsilon 90 in this direction. If you put the strain rate, this is 200. Okay, and at 45 degrees is 300. At this direction, which is 45 degree from here, this is 300. What is the principal strain? Maximum strain means the maximum strain means the principal strain. The maximum strain means principal strain. Tell me. आंसर तो दिया है. दिया है कहाँ? कहाँ दिया है? घोड़ा साहब. घोड़ा साहब मेरे को क्यों नहीं दिख रहा? Okay. So guys, what is shear strain? 2 epsilon 45 minus epsilon naught plus epsilon 90. So 2 epsilon 45 is 600 minus 400 plus 200. So that means shear strain in this plane, if this is x, this is y, 0. So if shear strain is 0, so this plane itself is a principal plane. That means xy is principal plane. Xy xy is principal plane. Give me yes or no. Xy is principal plane. And epsilon non, if this is principal plane, so that means epsilon naught and epsilon 90 are principal stresses. Oh, sorry, principal strains. They are principal strain. So what is the maximum? 45 or 400 or 200? 400. Papa ko ghoda, have you got it? Have you got it? Please tell me. Please tell me. Okay. Do this. Do this. Everyone. Do this. Tell me answers. The shear stress is very parabolic. Okay, guys, when this is the basic formula for all cross sections, okay, when you find this, suppose for it is this, it comes something like this, na? Cx BSD cube, applying this for any, for rectangular, it comes like this. So y square. Similarly, this for rectangular, for circular, for triangular, it comes y square only. So parabolic. Now, this one. Let me check who can give the fastest answer. The fastest finger first. The fastest finger first. Chalo. Chalo. Bata do. To ensure constant bending moment or the shear force is equal to dm by dx. If m is equal to constant, then what is shear force? Shear force is 0. Differentiation of constant will be 0. This you all know. I'm 100% sure. You might be knowing this. Okay, guys, what is the shear stress? Every time remember two things. Shear stress will be always 0 at top and bottom, mandatory. From that general formula, for any section, if you apply, it will be 0 at top and bottom. Always it will be a parabolic function. Always it will be at a parabolic function. It will be maximum somewhere at the interior. Maximum at interior. For symmetrical sections, it is maximum at neutral axis, but it can be others also. Like in triangular, it is not maximum at the neutral axis, not maximum at 2h by 3. It is maximum at mid depth, h by 2. Maximum at interior may or may not be at neutral axis. It can be anywhere. So 0 at top and bottom is here also. Parabolic variation is here also, but that variation is like this. The concave is inside, not outside. Okay. Okay, friends. Okay, friends. Okay. For an incompressible fluid, what is the value of Poisson ratio? For incompressible body, what is the value of Poisson ratio. C. Why C? Why C? Aspirant. Aspirant has given Vinod Reddy, Ghoda Sahab, Malesh. Why C? Because volumetric strain is sigma x plus sigma y plus sigma z into 1 minus 2 mu divided by E. If incompressible, so this will be 0. For making this 0, either this is 0 or this is 0. This may or may not be 0. It depends on you, how much you are applying the load. For any load, it should be no volume change, so this has to be 0. So 1 minus 2 mu is equal to 0. That means mu is equal to 0.5. Mu is equal to 0.5 for incompressible. Can you name some other material also? Rubber and perfectly plastic materials. Perfectly plastic material. Guys, this plastic region in stress strain curve, na? This plastic range in stress strain curve, this is also no volume change. No volume change in this range. Okay, so now you're saying the length is increasing, but other dimensions are decreasing like this, that no volume change. So plastic also, it is called as 0. Okay. Highest value of Poisson ratio is for rubber, 0.5. For cork, it is 0. Mu for cork is equal to 0. Mu for rubber, for incompressible, for perfectly plastic is equal to 0.5. And mu for ductile ranges from 1/3 to 1/4. And mu for human tissues and soap polymer is negative. Mu for human tissue and soap polymer is negative. Now this is the MSQ. Tell me, there is a boat, and in boat only one person is there. In boat only one. शक लौंडा है भाई, दो को नहीं घुमा रहा है. शक लौंडा है, दो को नहीं घुमा रहा है. ओनली अकेले घूमने निकला है वो. ऐसा नहीं कि सीएस की तरह दो लोग हैं, एक ही है, अकेले जिंदगी के मजे ले रहा है. Okay. First of all, tell me, this is simply supported. This will be boat is like acted like simply supported cantilever. What? It will be a simply supported cantilever or what? Tell me. Tell me, please. It will be a simply supported, or this is boat from where the upward reaction will be coming for balancing the 80 Newton. For balancing the 80 Newton, from where the upward reaction is coming. Tell me, please. 40. Support hai nahi, kahe ka 40. There is no support from where the 40 is coming. There is no support from where the 40 will be coming. No support. Guys, this 80 Newton will be balanced. There is not fixed here. Not pin support. This is boat, guys, not beam. This is boat, not beam. So this water is applying force here. So water is applying a UDL there. It is touching on water. It is the bottom floor of the boat is on water. So water will be applying the force, upward force. That will be UDL. Okay. So this is 80 Newton. And this for 2 meters, it has to provide 80 Newton. So this intensity will be 40 Newton per meter. So per meter 40, in 2 meter, it will be 80. Okay. Yes, aspirant. Now if I draw the SFD for this, na, okay. So upward and asset like this. Up from AN method, na, I told you AN method of drawing SFD BMD Abhinavnegi method. Loading is upward, positive and constant like this. Then downward load like this. Then positive and constant. And shear for this is SFD. Guys, how I made in 2 seconds? If you don't know, then watch the AN method of SFD BMD. Watch the AN method. AN method, you can draw all the question in this word just in 2 seconds, SFD and BMD. Now, positive and magnitude wise increasing. So BMD will be like this. Negative and magnitude wise increasing. No. Positive and magnitude wise increasing, correct. Negative and magnitude wise decreasing, correct. So this will be BMD. Okay, for symmetrical, SFD is always anti-symmetrical, BMD is symmetrical. SFD will be linear, BMD will be this. SFD will be actually anti-symmetrical, BMD will be symmetrical. No, only answers correct will be A and B. Only answers correct will be A and B. Got it? Goda Sahab, Aspirant, Satya, everyone. Understood? Understood? Okay, tell me this. Tell me this. Yes. Work done by the body. No, aspirant, no. Let me explain the whole concept. Leave the question. Let me explain the whole concept. Leave question. This is a bar. In this bar, I apply the P force. With application of P force, the deformation is delta because this is a deformation delta. If it is rigid body, then there is no deformation, but we are studying SOM, so there will be deformation. So we are doing some work, work as stored as energy. I am doing some work is stored as energy released. I am doing some work is stored as energy released. I am doing some work is stored as energy released. So work done is force into distance. Work done is force into distance. Now the force is not P. Force is not P. All the loads in the SOM, there are some, for every SOM, it is understood that not mentioned the weight should be weightless, Hooke's law is valid, and load is gradually applied, that is static. Load is gradually applied. So it is not P load application. Little bit to 0, then more, little bit more, little bit more, little bit more, then P load. So if anywhere SOM is written P, that means that P is not applied suddenly. By default, it is gradually, little bit more, little bit more, little bit more, little bit more than P. So for the whole delta, the average load is 0 plus P by 2 because it started from 0 and then N to P into delta. So work done is half into P into delta. Now, if I make a P delta curve and Hooke's law is valid, then it is straight line. So this area is strain energy because work done is strain energy, na? So here also the area of triangle is half base into height. It is half P delta. So area under the P delta curve is strain energy. Now area under stress strain curve. Okay, this. So this is P by area. Strain is delta by L. So here the denominator will be area into length, that is volume. So here it is strain energy, but denominator area is coming into length. So denominator volume. So P delta curve gives strain energy, but stress strain gives strain energy per unit volume. So this strain energy density. Density means volume. A option. Okay, work done by the thing is strain energy. If it is written area under the P delta curve, if it is written area under P delta curve, then you should be showing it is strain energy or it is work done. If it is area under the stress strain curve, it is strain energy per unit volume. Give me yes or no. Maza aa gaya aspirant? Aspirant enjoyed? Aspirant enjoyed? Understood the concept? Ghoda Sahab, Satya, Meghat, everyone. Great, great. Thank you. Thank you. Now, a material is referred to as a perfectly rigid if modulus of elasticity is how much? Guys, these days we are taking the ESC mock interview. In ESC mock interview yesterday, I asked this. So out of 5, only 3 are able to answer. So the students who qualified the prelims and mains, out of 5, only 3 are able to tell this. Can you please tell me? Can you please tell me? Young, nobody, you, A. Okay, so you are more intelligent. 2 out of 2. Strain is 0 for rigid. So this is infinite. Okay, also you draw the stress strain curve. And stress strain curve is like this. Stress strain curve is like this, no strain. So tan 90 is equal to Young's modulus is equal to infinity. Got it? This one. At room temperature, the rods are shown in the figure. Temperature is raised. What is the nature of stress? And when supports are unyielding, unyielding means they are rigid supports. Unyielding means they are rigid supports. Hit it. Hit it, guys, everyone. Everyone. Hit it. What is D? A. Okay, those who are saying D, guys, it is not composite. Rigid. The difference, this is the student does mistake. They see something here, they assume it is composite. Guys, it is rigid. Even if aluminum wants to increase more, okay, steel wants to increase less, but both can't increase. In composite, what happens? That one wants to increase more, one wants to increase less. So they increase up to this point because delta is allowed there, but same delta. Composite means delta can be there, but same delta. So this will be in compression, this will be in tension. But here is fixed. Both cannot elongate. So both cannot elongate. Both should be compression. This is not the case of composite. This is not the case of composite. Understood? Understood? Everyone? Okay. Which are the values of mu can be possible? All are this plus. Which are the values of mu are possible? Tell me. Guys, for metals, mu can only be positive and up to the value of 0 to 0.5. So this is not possible in MSQ. Okay, this is not possible. For the state of stress, the major principal stress is 10. Okay, sigma 1 is equal to sigma s plus sigma y by 2 plus minus sigma x minus sigma y by 2 whole square plus tau xy whole square. And sigma 1 is equal to coming 10. So what is the value of shear stress? Simple. Simple. Tell me, please. Tell me, my friends. What will be the value? Tell me. Tell me. Tell me. Everyone. Everyone. बता दो. B. Okay, so this 10 is equal to sigma x 5 and 5. 10 by 2 is 5 plus 5 minus 5 is equal to 0 plus tau xy square. So from here, the tau xy is equal to 5. Tau xy is equal to 5. Okay. The term pure bending means bending moment is constant and shear force is 0. MSQ. Yes. Are placed one inside the other so as to compress by the same. Oh, one. This is nice question. This is nice question. This is nice question. One is this, having spring constant Ka. Another is this, spring constant Kb. What is the equivalent? What is green or yellow ko mila, I'll get this. This is a nice question. It is series or parallel. I see, either the answer will be, wait. Either the answer will be series wala or parallel wala. Okay, this is no answer. So either A, B, D, and let me just take is 2. So this is also not anything because both of them are same answer. So either it will be B or D. So either the answer will be B. If it is parallel, the answer will be D. If it is series, answer will be B. Or if you are not able to understand like this, then let me take this as 2 here. So this is no formula. So either the answer will be A or D. If it is series, then this. If it is parallel, this is a beautiful concept, guys. Here, this is a beauty concept. Okay, that is the thing now. What students, those who studied from me, every time I tell you the logic. Okay, so they think this is series. Ye series hota hai. What is series? Into there, somebody is asking. This is series. What is parallel? This is parallel. Same thing I told you in equivalent permeability case also in soil mechanics. Parallel to bedding plane is not like from figure you are thinking parallel to bedding plane. Okay. So that also the concept I told you here there also. Why a thing is parallel, in what conditions it is called a parallel to bedding plane for finding permeability, and when it is perpendicular. Now tell me it is series or parallel? If it is series, the answer will be A. If it is parallel, the answer will be D. Nice question. Nice question. Tell me, friends. Guys, the series we call when load is same. Okay, this is P, and here also the load is P. If you're not understanding, this is P, so reaction will be P. So in this also the load will be P. When load is same, it is series. Here, parallel means when deflection same. Delta is equal, this is the concept, when delta same, they are parallel. That is why this spring is also parallel. If this block is moved, sorry, this is fixed support. If this block is moved here, so elongation of this and contraction of this is same. So that is also parallel. Now I am applying a P load. Okay, so of P load, guys, many questions you have done like this, na? This is some and this is one material and two material. They are composite or whatever. If P load is applied, so I don't know how much is going in P1. I don't know how much is going in P2, but P1 plus P2 is equal to P. If P load is applied here, then how much is in going 1? I cannot say P by 2. How much is going in 2? I cannot say P by 2. But yes, P1 plus P2. If P out of P, P1 is going here, P2 is going there, then P1 plus P2 is equal to P. Similarly, I don't know after applying P, how much is going here, how much is going here. But if they are one another, okay, and they compress by same amount. See the thing. They compress by same amount. Delta is same. So it is parallel. So it is parallel. The answer will be D. Give me yes or no. Understood this beauty concept, guys? Otherwise, this is series. Niche series. And this is one, this is parallel. This is not concept, na. Tell me, please. Tell me, please. Have you understood? Have you understood? Enjoyed? Enjoyed the concept? Now, tell me the equivalent stiffness of this. Now, these two are in series. So, K equivalent is equal to 1 by 10 plus 1 by 40. So, K equivalent is 44 by 40. 40 by 4 is 8. So, this I can take it as 20, 8, and 30. Okay. Now these three are parallels. So 20 plus 30, 58. So this is 58. Have you understood? Have you understood? Everyone? Everyone, please. Okay. Closed coil helical spring is this one. P load is applied. Number of turns is N. The mean diameter is R. Modulus of velocity is N. Okay, we generally represented G, but this is N represented here. And diameter of this wire is D. Then the elongation of the spring will be. The strain energy of the spring is given by. Strain energy is 32 P square R cube into N by GD4. Correct? 32 P square into R cube into N GD4. What is deflection? Del U by del P. So differentiating with respect to P, it will be 64 P into R cube N GD4. 64 P R cube and G means N. G means N. That will be option number D. We know that it will be A. Satya correct. Sahib Mishra correct. Okay. So guys, this is the course for mechanical. Similarly, it is for civil also, CE also, EC also, CS also. 90% is the scholarship. This will be on 24 September. If you give the free of cost test, you can get the 90% scholarship. And last 120 days preparation strategy to ACE Gate 24 by Richa ma'am. This will be on 27 September at 7:30 PM on app. Okay. Now, this is the Telegram group of Dheeraj sir, mechanical by Dheeraj sir, and this is the mechanical by civil sir. Mechanical by civil bol raha hu main. Mechanical by civil. That is civil by Abhinav sir. Okay. Already more than 5,000 students have enrolled here. Now, guys, a very important surprise. Every time the gate is releasing the statics of the previous year gate, every time. Gate 2023 was conducted by IIT Kanpur. So the static have been released. So I have made a video, just published it 1 hour before on this YouTube channel only. You can see this in the video section. In the video section, that is this 12-minute video. There will be finding the mean of all the candidates. 11 marks is the average of all the candidates for civil mechanical both. Marks average of top 0.1%. 30 to 40 marks, how many students are there? 40 to 50 marks, how many students are there? 50 to 60 marks, how many students are there? Every data is given there. You can see this. Okay. So I hope you enjoyed, guys. Thank you. Thank you all. Take care. Keep sharing. Thank you. Thank you, guys. Thank you all.